Hello, this is Brett the STEAM Tutor, and in this video we're going to be doing a cache architecture problem. The problem says, for the following cache architecture, indicate the number of bits in the table for each field. And they tell us that the address is 41 bits. Okay, so let's just start with the first row, the fully associative. I'm going to label that row F. Alright, so the first thing you're going to want to do with all of these is find the number of blocks, which I'm going to label BL. And the number of blocks is going to be your cache size. Over your block size. So here we have a cache size of 2 to the 4. And 2 to the 10 over 2 to the 4. So what I'm doing is I'm taking the fact that there are 16 kilobytes. 16 is 2 to the 4. And then the kilo is 2 to the 10. So we have 2 to the 4 times 2 to the 10 for 16 kilobytes. I'm going to put that over 2 to the 4 for the block size of 16 bytes. And that's going to be 2 to the 10. Next, we're going to want to find the number of sets. I'm going to label that S. And for fully associative, that's always just going to be 1. Next, we're going to want to find the number of index bits. I'm going to label I. And that is going to be log base 2 of S, which log base 2 of 1 is, of course, 0. Next, we're going to want to find the block offset, which I'm going to label B. And that's going to be log base 2 of the block size. That's going to be log base 2 of 16, which is going to be 4. Now, we have to find the number of tag bits. I'm going to label that T. And that's going to be your address bits minus your index bits minus your block offset. So that's going to be 41, which was the address provided. So I'm going to write this A, which is our address bits, is 41. Minus I, which is 0, minus our block offset, B, which is 4. And that's going to give us 37. Okay. So let's make some space here. Let's fill out the table. So we found our tag to be 37. We found our index to be 0 and our block offset to be 4. Okay, let's move to our two-way associative. Just going to label that TW. So here our block is 32 bytes and our cache size is 32 kilobytes. BL is cache size over block size, so cache size of 32 kilobytes. Well, that's 2 to the 5 times 2 to the 10 divided by block size. What was our block size? Our block size was 32, so that's 2 to the 5 also. And that's going to be 2 to the 10. Next, we'll find S, number of sets. That's going to be BL over number of ways. So we have 2 to the 10 over 2 ways, so 2 to the 1. That's 2 to the 9. Next, we find our index, which is log base 2 of S, which is going to be 9. Next, we find B, our block offset, log base 2 of 32. Going to be 5. And then our tag is 41 minus our index 9 minus our block offset B, and that's going to be 27. So let's fill out the table. Okay, so next let's do our 4-way. So here our B, nothing has changed. Our cache is the exact same and our block size is exactly the same. So no need to calculate that again. We just carry our B over. Our sets did change though, because now we're dealing with 4-way instead of 2-way. So we take our B, which is 2 to the 10, and we put it over the number of ways, which in this case is 4, or 2 to the 2. And that's going to be 2 to the 8. Alright, next let's find our index, which is just going to be log base 2 of S, which will be 8. Our block offset is going to be exactly the same. And now let's calculate the tag. We have 41 minus 8 minus 5, which is equal to 28. Okay, almost done. So we had 28, 8, and 5. Alright, next let's do the direct mapped. I'll label that D. So BL is equal to 2 to the 10. Our S is our BL over number of ways, which is just 1 in direct. So that's just going to be 2 to the 10. I is just going to be log base 2 of S. So it's 10. Our block offset, nothing has changed. So we just carry over that 5. And then we finally calculate the tag. 41 minus 5 minus 10. And I think that's 26. Quick math in my head there. Okay. So yeah, 26, 8, 5. All right, that's it. Real simple. I hope that was helpful. If it was, please subscribe.